Right, so we're going to start with a Eurosonic ES200. I seem to have picked up a cold, so if I sound like first class ticket to Nottingham, that's probably about where we are. So, this is one I used for a week or so when I came back to CB. It seems to work okay. Good. Well, that's a good one to start with then. He's had these for about 15 years, he says, and he got them from a car boot for £20 a pair. All I've got to do is get in it. Oh, got there. Take that body bound screw out. Oh, it doesn't look like it's full of water, which is always a good sign. No, I can't remember whether we've got to take this out. So we'll just have a very quick look. Yeah, the frequency trimmer's there. Right, I'll pop those screws back for the time being. Loosely. And remind ourselves what sockets it's got. So we've got an earphone socket, which means we can actually plug it into the test gear. External 12 volts. We can soon do our power lead for that. And it is positive inner. So it's a 12 volt radio. So we'll get that set for 12 volts. Oh, it's up down, is it? Okay, switch picture in picture on. It's on. And let's have a look at what it's doing on transmit. So I'm at 12.8 volts, which is the maximum I'm going to take it to. We'll go on the 3 watt scale, and it helps off with the aerolin. So it's a BNC, so we'll just put an adapter on it. And that's 2.7 watts. So that's nice and healthy. Right, I'll go and download my instructions and just print them off. See what it's supposed to do. Right, well, I haven't got an instruction book on file for these. Oh, we're still on channel 20, yeah. But I have got some notes I made last time, and I think we got 2.7 watts as a peak. The last one came in doing 2.5 watts and we got 2.7. So the fact this is doing 2.7 is right on the money. So I think we'll start by doing the frequency. So we're going to transmit, and let's see what we've got. It should be 27.79125. And it's slightly low. It could be low enough to be able to spec that. So we'll see if we can get to that trimmer without taking that subboard out. Oh, that's nice, isn't it? You take the trimmer out and it changes. We'll leave it at that. It's got some room to drop there. Right. We'll run through the transmit. So we've got 1, 2, 3 and the coil there. So we'll go back to power meter. They're all peaked. That wasn't. It's now about 2.8 with it being warm, so that's an improvement. Deviation. Well, we've got no alternative but to whistle into the microphone. Well, we use the little oscillator, but we'll just see what we get. Now, I think we were doing a set with CPT last time, so we'll just have to retune the machine. Wallow, there we go. Wallow. Do you know what? It's spot on. Wallow. It is absolutely spot on. I'm not going to go any further. So your deviation control is the preset there. We're not going to touch it on this occasion. So off frequency, we've been able to get a little bit more power out of it. There's the frequency adjust. So we've got 2 of these to do, so we'll probably do them both back to back, and I would suspect that one doesn't work at all, and I've picked at random the better one out of the 2. I may be wrong. So we'll look at receive. Right, let's have a listen. So I'll plug the cyanide meter in. And let's see what we've got. Select that on there. So for 12 dB, it's about 12 Well, very good, 0.38 microvolts. So I'll put that on there, 0.38 microvolts. Set 1 was 2.7 watts, now 2.8 watts. Was 27,790, it was 4.8, and now it's 27,79129. So, let's see where with. First of all, we'll do the detector. So we'll go over to the oscilloscope, put a meaningful trace on. So that's S9 equivalent, 100 microvolts. And I'll just turn the bench light off so it's a bit more visible. And the detector coil is that one. Well, there's an improvement. Right, we'll go over to the cyanide meter and see whether we can get a little bit more out of the receiver. Though it's working very well anyway. So we'll take it to about 4 dB, so we're not saturating the receiver. And the front end, we're looking at these here. I've got a little bit more out of it. And this is going to be IF. Put a bit more signal on. I think we're about at peak there. So what's that give us now for 12 dB cyanide? Absolutely no difference, 0.38. Okay, so there we are, we're at peak. We'll just check the squelch. So with the squelch to full, we'll set the attenuator. See if we can bring that in at the 100 microvolt point. We can, that's spot on now. Now we'll look at the sensitive end of the squelch. Turn the signal generator to standby, set the squelch to threshold, switch the signal generator back on, but it's parked at 0.3 of a microvolt, straight in. So it's coming at 0.3 of a microvolt, it's leaving at 0.22 of a microvolt. So let's see what we can hear it down to. So look, I'll just turn the squelch down, 0.3, 0.25, 0.2, 0.15, 0.1, I can still hear that. Then we'll put the tone, take the tone off and on. It's just there at 0.1 of a microvolt. So that's very, very good. So we'll screw that one back together. Oh, I know what I didn't do. Make sure those are tight. Out of interest, let's see what it does on low power. Back to transmit. So we're on the 3 watt scale on the test set. Transmit. These are fun, aren't they? So from cold it's doing 2.9 watts, and in low power it's doing 0.4, which is excellent. We've got a tone switch. Can't hear that making that any difference at all. Oh well. Can't say I'm that bothered. Right, we'll get that screwed back together. Okay, there's the case back on. Let's see what happens, whether we can press these switches. Just about. Don't know what size fingers you're supposed to have. Okay, so that's that one done. So I'll go over to the box. We'll do a scratchy corner test on this another day. So on to the other one. He says this one seems to bleed over on transmit. There's a tiny nick on the top of tool. Put some heat shrink sleeving on the aerial. But not that we're here to fix aerials, you know. Just like we're not here to fix mics. Right, this is scruffier. Open the battery compartment. So it's either going to be off frequency slightly, or it's going to be the deviation too high. It'll be one or the other, or both. So once again, we don't have any ingress of moisture in there, which is great. No, that looks excellent as well. That's nice to see. They're dreadful, these little switches. Right, get plugged in. Back on just to kind of protect it. Change it to channel, just making sure it goes in both directions, because those switches can be a bit iffy. Without the filter you can hardly see that. It's got the squelch action. So we'll plug in the aerial, which is the test equipment, and we'll do the same again. So it was 2.7 watts and we got 2.8, wasn't it? So picture is on. It's in the wrong position there. I want it in that position. Here goes, transmit. .6 watts. So let's see if it's on frequency. More on frequency than the other one was. Just make a note of this. Set to 2.6 watts, 27.79. Oh, it is low. It is low. 02. Yeah. Yeah, it's quite a bit out, that. I'm going to waggle that around a bit just in case there's some nastiness. They don't like even these ceramic trimming tools, do they? So it's about where we were with the other. Give it some room to drop with age. So run through the transmitter, which is quite healthy. So that's fine. Oh, we're not on the right screen. Let's go back to that. So the first transmit one was okay. The second transmit one is okay. The third transmit one is okay. And the final one .8 watts. Deviation. Now, is it over the top? Wallow. It could be minutely. Wallow. Oh, it is still. Let's drop it a bit more. Let's try it there. Wallow. 1 2 1 2 1 2. Wallow. Now it's too low. One to wallow. That's it. That's it. We're there. 2.2 to 2.5 absolute maximum. So that's the transmitter covered on this one. Just check it's still on frequency. Yes, even more so. Out of interest, what's low power doing on this one? 0.38 watts. And the receive. That sounds awful. Let's see what the sign meter says. Right, it says it says 0.62 microvolts, so it's not nice. Let's see if the detector's out. It looks pretty awful, you see. Switch to the oscilloscope. Well, that sounds better. Let's do the IF. That's looking better. Right, we'll do the front end now. There's no improvement there. I'm just wondering if it's lopsided on receive. I'm going to change the frequency and see whether the cyanide gets better. Higher it's worse. Lower it's worse. Just double check that detector. So our cyanide meat reading is now, where were we before? It's just the same. There's no improvement at all. Alright, we'll just pause the video. So there's another coil which affects the detector, and that's here. So I've just peaked that. Let's just go back to the original one as well. This is the trouble when you haven't got a circuit diagram, you're doing a bit of educated guess. It might be that that's IF and the other's the... Let's go back to where we were. It doesn't sound horrible now. And the cyanide is now what? 0.68. It's not made any difference to that. But it does sound right now. So there is a tolerance between the sets, and that's what you'd expect. But I think it was off frequency so far that that's what his complaint was. Right, we'll put this one back together. Okay, so we've put that back together. Hopefully we'll change channel successfully. See whether the tone makes any difference on this one. I can't detect any difference. They're still awful switches, whichever way I look at it. Right, we'll put it onto the aerial instead of the test equipment. Well done, Roger. Well, I'm not hearing anything on there. So we'll plug the other one in, which is slightly more sensitive. Well done, Roger. No, there we go. So there you have it, 2 Eurosonic ES200CBs. Considering these are about 1991, they're now 30 years old. So we're doing on-the-air tests. We'll do both of them tomorrow. I'll have them on the bench. Mr Chippie will drive away as usual. We're not doing field tests. We've already tested these kind of radios in the past, and it's not really good weather to be walking down the road with them. So there you go. The Eurosonic ES200CB on 2781 UK FM from 1990. Thanks for watching.